Welcome to Feature Fridays, where we make a feature for your game on Friday. I'm feeling especially dead inside this morning.
Oh, brother, this guy stinks!
So, what we're going to be making today is a sliding door. I mean, who doesn't love putting those in their games, right? You like those, don't you? So, sliding door. Regular doors aren't cool. I mean, you get a door, you got a pivot, it rotates. This is cool, but I mean, if you got like a lab, a factory, isn't it so much cooler to just have the door slide vertically and make a nice snappy sound? Sliding doors, they're cool. They're interesting. They're so much more fun and creepy than regular rotating doors. You got a SCP game, you got a role play, a lab, you want that secure vibe. You need a sliding door. So how do we make a sliding door? Well, I've got this model here, and of course you can get all of this by watching the video, copying my code, all that jazz, but if you want to just cheat, you can check out the link either in my description or top comment, depending on if YouTube's going to let me throw a link at you, but it's going to have the model on my website, definitely-not-seal.com. Right there, you just click download, get the model, it's all free. So I've got the model here. We've got a frame and a door, and the frame is important. When we make the door, obviously we're going to have to drag it upwards to about here. That's why it's extra tall, is I kind of want it to stop at the diamond plate. But, you know, we don't want this door glitching through our wall. If you have two pieces of the same size, they glitch. So that's why I'm going to stop the door here, but it needs to kind of retract into the wall right about here. And so it's important that your wall is, or your frame is slightly taller than the size of the door, because we're going to need to basically hide the model inside of the wall. So we've got a frame and a door model. I'm going to put our door model in place. Once you build the door here, stick it all in a model and make sure it is all anchored. Same with the frame. Make sure everything's anchored. If you want to do it cheat, just click the top model, anchor. Anchors everything inside. So we've got the door in the frame. There's one extra step you're going to need to do, and that's create a detection box. In this one, pretend like that didn't happen. In this one, I've got this small box in the center of where the door is going to be. The reason we're going to be using this is for our proximity prompt. So you stick an attachment inside of it. Inside the attachment, you stick a proximity prompt. The reason we do that is so when we hit play, we've got the prompt just right here. So that's what this detection box is for. I'm going to make it invisible, and basically this box is just going to hide here. This isn't going to move with the door, but this is just going to hold where our proximity prompt's going to be hanging out. So to set this up so that it works, we need to make sure that the door is anchored, but all the parts are in a model, and that you grab this center piece, whatever this is on your door. This could be an invisible part covering the entire door, or in my case, this is just the piece of the door here that I want to move. Make sure that this piece, you go into the model here and find this primary part variable or property. Make sure that you set this to the centerpiece, or whatever the primary part of your model is going to be. That's really important, because if you don't do that, the script isn't going to work. So make sure that this model here, again, has a primary part, which is going to be the moving center of the door. If the door has a billion pieces and you're bad at modeling, that's okay. You can create basically a shell that hovers over the size of the door that's invisible, that you just use as the center to move. So make sure the model has a primary part. Otherwise, you're going to be posting a comment going, "Oh my god, the script doesn't work!" Ah! Okay, so that's how to configure your door. Then for the proximity prompt, like I said, make sure the part's anchored and it's invisible. And here's another hot tip. Turn off can collide, or your character as they're walking through the door is going to bonk their head right here on this cube. So attachment, proximity prompt. Let's configure our proximity prompt. Saying interact's kind of lame, so I'm going to go over here and I'm going to set the max activation distance to 15. That's the distance, basically how far away you need to be before it disappears. So 15 studs away, the prompt's going to disappear, versus if you're within that 15 stud barrier, it shows up. So 15 means you got to get a little close. I'm also going to set the hold duration to 0.25. I personally like hold duration on prompts. I don't like it where you just tap the button and it disappears. Object text, we're going to call it a door. And interact, I like that. We could do open, close. I like interact though, just because it's very generic. Turn off requires line of sight. Basically, if you're like here, prompt will disappear because there's not a ray cast, or there's not a straight line between your character and the door. You can mess with line of sight. Line of sight's good if you need it to where like, you know, they should have their mouse on the door for it to open. It's just with modeling and stuff, it could be really easy to have an invisible part covering the prompt, which in that case it would cut the prompt. So play around with it. Obviously, you want to be messing with these settings and not just, you know, using the default settings. So this is what our prompt looks like right now. I'm going to use play here. You can do it from a good distance away. Get close. You have to hold it down for just a second. I like that. I like a little bit of play here on the button, a little bit of load time. Okay, so now that we've set this up and that it is how it should be, let's get to scripting. Throw in a script inside here. Now, before we start just throwing the script together, I'm going to throw down some comments and let's plan out how this is supposed to work. So our door is anchored and the collision is on. Reason this is important is it's anchored and the collision is on, meaning it's not going to move on its own. You're not going to be able to push the door open. And because the collision is activated, it's going to collide going through objects, meaning you cannot use the physics engine. So we're not going to be using physics, not using physics. I hate the physics engine. Really buggy. We're going to be using C-frame. So we'll say using C-frame. Now, what we need the door to do is basically have two states, closed and open. So the door is going to have two states. Here's the description of how it's going to work. Description. Door will have two states, open, closed. So this is the open position. This is the closed position. Basically, we're going to need to tell whether or not the door is in the open position or the closed position, and then reverse where it's currently at. So that's our first big piece, is defining the state of the door. State is basically like the status of the door. What's its current state? What's its current status? Most of you are probably too young to actually deal with finances or any financial transaction, but basically when you buy something on a credit card's a good example. You buy something on a credit card, it has a status. First, the transaction's pending. They're checking your bank, seeing if you've got the available credit. Then they run the bill. Once they charge your card, then the state goes to finished. You've got a completed state where basically it's in limbo for 3 days, and then they mark it on your account. That's state. What is the door doing? What position is it at? Not position as in like, you know, position in the world. What status is it? Is it open? Is it closed? Is it moving? Each of those are a different state. So we need to have a state machine, 3 actually, open, closed, moving. The reason states are important is because we need to determine how the player is going to be able to interact with this based on each state. If it's in the open state, triggering the prompt should move it to the closed state. It should shut the door. If it's in the closed state, we should do the reverse and try to open the door. And in between each of these states, we should be moving. The reason we need a moving state is you shouldn't be able to open or close the door while it's moving. So we should check the state. If the state's moving, we should just yield the script. We shouldn't really be doing anything while the door's moving. Otherwise, you get these really weird interactions where it's like, woo, 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 ooh, ooh, ooh. Okay, I'm going to name my script. We're going to call this control. You can name it whatever you want, but I like to name scripts. If you've ever worked on a project with somebody else and they have a bad naming convention, like everything's named model, everything's named part, scripts are named like underscore or something stupid like that, then you know how difficult it is to work in a place like that. So don't be a noob. Be good. Strive to make good code. Name stuff in a very easy to understand way. Use good punctuation. Doing that is already going to put you way above others in terms of scripting. You know, just the people that I meet and see on this platform. So I want you guys to not just know how to script, but know how to script good. That's really important. So 3 states. What else? We need to move the door through C-frame. Move door with C-frame. C-frame is a special type of positioning. I'm sure we're all familiar with the size and the position variable. Position is vector 3, x, y, z. C-frame uses vector 3 for positioning and orientation, both together, plus like 27 something other values. C-frame is basically a global position, local position, global orientation, and local orientation. It's a very complicated value. So we're not going to go into the mathematics of how C-frame works. That's linear algebra. It's the same type of stuff we use with the camera. Very, very advanced mathematics. You learn. I don't even think they teach that in high school, if I'm being honest. Linear algebra is like you've got trigonometry, calculus, then like AP calculus, and then above calculus, you've got linear algebra, which is a much more complicated mathematical sector, whatever you want to call it. You know, big words make me confused. So we move the door with C-frame. We could just pop the door up here, but I want it to go smooth. So what we're going to do is we're going to use tween. Tween service basically says, here's position A, move it to position B, and then it's going to do it in a really smooth manner. So instead we move it nice and smooth. Now, the complicated part of this is it's easy to move a part like this. The problem is we're not moving a part though, we're moving a model. So because we're moving a model instead of a part, all these need to be moved at the same time. Now, it's really stupid to go through each of these and try to individually move them together in tandem. That's really dumb. So a very easy workaround is we can weld all of our parts to our center and then just move our center. And everything else will follow because they're all welded. That's how we move a model. So this part's tricky. We need to weld each of these pieces to center. Now, to do that, you could go to Model, go to Create, and create a weld. Here we go. And just click the pieces individually. I've got these two selected, Show Welds and Constrain Details, and they actually show you the welds. So we could do this. Actually, let's just do this. This is really easy. I didn't realize how... Okay, that takes like 2 seconds. So we can do that and just weld this whole thing together. Let's unanchor all of these parts. And now our welds are active. So these are unanchored. Our center is still anchored. So that way these can't move around because they're welded. But if we move center, because they're not anchored, they all move together with center if we use a special function from the model. If it's a really complicated door piece and you don't want to individually go through each line, you can actually run a command here in the command bar welding everything. But I guess if you're watching this scripting tutorial because you don't know how to make a sliding door, then that's probably not feasible. I don't know. Let me know in the comments. I can make a tutorial on that, on how to weld all the parts of a model together through script and then do it in the command bar. That's usually what I do for stuff like this. So door is welded. Let's move the door. Weld the door, move it. Okay, so we have some pieces. Let's start with our variables at the top of the script. We're going to need tween service. Remote bit get service, tween service. So if you don't know variables or functions yet, go to my website. I have a scripting course called The Basics of Roblox Luau. Costs 25 bucks at the moment. I'm not trying to sell the course to you. What I am doing though is you can actually get the first 2 modules for free. That covers variables and functions. You don't have to pay anything. That's all completely free. Head down to my website. Again, if you don't know what variables are or functions, go get that course for free, the first 2 modules. Watch those. You can either do it, before you come back, or you can do it on your own time, but that teaches everything you need to know for variables and functions. Super useful. It's free. Go check it out. We need to get tween service. Tween service is a bunch of built-in functions that let us smoothly move a part to a position. Remember how I described it? We say, here's point A, here's point B, and here's our part. Move it here, here's how. That's what we need to provide to make a tween. So we get tween service at the top of the script, and then we're going to need our state. We're going to call this state. Our current state is closed. We'll do lowercase. Closed. So we've got 3 states. That's our first state, is closed. This is going to be how we determine what the door is doing. This is a string, so we got to slap 2 quotations. Let's write our function and our connection to our proximity prompt right here. Let's get a variable for our door model. That actually would probably be a little easier too. So we'll say local doorway equals script.parent. So we'll say local function on triggered, open and close parentheses, hit enter. We just created a function. So let's get our proximity prompt. We'll say local prompt equals doorway dot detection dot attachment dot proximity prompt. Now proximity prompts have this event called triggered, and this goes off whenever a player activates the proximity prompt. So we'll say connect on triggered, just like this. And what this is going to do is whenever they trigger the proximity prompt, this function is going to run. Now when this happens, it passes in the player that activated the proximity prompt, the user, their player file that's going to be in here. So we stick in the parentheses player to catch that variable, that argument, and now let's open the door. So because we're working with state, we need to change and update the state. So let's do this. Let's write 2 functions, local function, change state, new state. So what we'll do is we'll say if state equals closed, then, so we'll say if state equals moving, then return. If the state is moving, if the door is in the middle of moving, end the function. And we'll say if state equals closed, then we'll add an else. So if the state is closed, this will run. Else, because it's not moving, because we're ending the function if it is, that means the state is open. So else, then both of these will say local new state. We're going to set new state. So new state's going to be open. Unless it's already open, then we're going to set new state to closed. So we build a value, new state. If the current state is closed, we set it to open. Otherwise, we set it to closed. Then we say change state, new state. Now, inside of this change state function, we're going to either open or close the door depending on where it's at right now. So we'll do a new variable, local current state equals state, and then we'll say state equals moving. Now, current state, we're setting to state before we change state, so this is going to be the previous state. Let's say we hit the prompt, state is closed, current state becomes closed, then we change state to moving, current state is still closed. So what we need to do now that we've got the state changing part done, is we need to move the door with the C-frame. First thing we need to do is get how much we need to move the door by. So this is our door. In order to move this door where I want it to go, we need to move it by 8 studs. Positive for down, negative for retracting. I'm sorry, positive for up, negative for retracting. Now we could just hard code the number 8. The problem is though, what if we want to change the door size? Then our code's going to suddenly stop working. We have to manually go into the script and adjust to the new value. So what I'm going to do is I'm going to make a bold assumption and say the primary part of the door is going to be what we want to move it by. So center, which is true. We want to move it by center's size. So what we'll do is we'll just take center's size or door.primary part and use the y there for what we're going to move it by. So we're going to say local size y equals doorway.door.primary part.size.y. So this gets us the y value of our center's size, which in this case is 8 studs. So now what we're going to do is to get the position we want to move it to, we say local move to position equals doorway.door.primary part.position plus vector3.new. 0 for our x, size y for our y, and 0 for our z. So this is the new position that we want to move it to. Now here's the thing. Whether we will move it up or down is going to be based on if this is a positive or negative number. So what we're going to do is wrap a new function, say local function, get move to position. We'll slap this in here, and we will say size y. Now here's a little logic we're going to do. We're going to say if state equals open, then size y equals negative size y, and then we'll throw this in there. So if it's open, we invert the size variable. So instead of 8, it becomes negative 8, and we use that to close the door. If it's not open, it's closed, and we basically will be able to, we'll use the positive number to move it upwards. Now, because we're doing this, it's a good idea to change our state after we get the move to position. So local get move to position, size y, move to equals, there we go. So local move to equals get move to position, size y. Down here, we'll set our state to moving, and then what we'll do Okay, so sorry for you guys who are following along. I actually just caught something. We're not going to need our current state variable. For some reason, I was thinking we were going to use that to adjust the state to what it needs to be, but I just remembered we're actually doing it right here. So we're going to set state to moving, and then when we're done, we'll set state to new state. So state to moving, and then in between here, we're going to have all of our code. So here's where we're going to create a tween, and then here, after tween is done, set state to new state. So to create a tween, we need a few things. We need a property table, we need the thing that we're trying to move, and we're going to need a tween info. So let's create a tween info. We'll say local info equals tweeninfo.new, and this is our settings. So first we need the duration, the time. How long is it going to take for this tween to finish? Let's try 1 second. Next, we have the easing style. The Roblox Developer Hub has a great page on easing styles and what they look like. I'm going to say enum.easingstyle.quad. Basically, we want it to slow. I want it personally to slow down when it nears the top. And so because I'm wanting it to slow down when it nears the top, we're going to do enum.easingDirection.out, meaning it's going to play at the end instead of the beginning. And I don't think there's any more arguments I personally want to add, so we won't have a quotation at the last one. So that's our info, then our property table. Local goal, we want the C-frame to be doorway.door.primaryPart.cFrame times cFrame.new move to. So what we're doing is we're grabbing our door's current C-frame and we're multiplying it by a new C-frame with our move to position. Now what's cool about this is because we're using C-frame, we could actually, if we have some fun math, move our door like this. We could actually move it to the corner if we wanted to. If you want to do a rolling door too, you could use a cylinder and you have it rotate and move to the position at the same time, all by using C-frame. So that's the cool thing about C-frame is it's a lot more versatile than just vector 3s. So we've got our info, we've got our goal. Let's create a new tween. New tween equals tween service :create. Then we need to provide what we're moving, which is going to be doorway.door.primaryPart. We need to provide the tween info, which is our info, and then our property table, which is goal. Then we say new tween play, new tween dot completed : wait. So what this is going to do is this is going to play our tween, and then we're going to wait on this event completed to fire. So it's going to pause the script right here until it's done, and then we'll set our state to our new state, opposite of whatever our current state is. Lastly, I'm going to go into the toolbox real quick and get a sound effect that we'll use that we're going to play right here. I'm also going to be sneaky and test and make sure this code works really quick before I just... What the? Okay, so I got our sound effect. We'll call this move door, and we'll throw this inside the center part because this is where I want the sound to come from. And so we will say doorway.door.primaryPart.move door play. This is still the primary part, right? Yes, it is. Okay, so I realize there's a couple of issues with our code. So follow me, we'll make some corrections. First, I forgot to return this position. So we'll say return move to position. We'll send this back to move to, and then we'll combine our C-frames here. There's one last hitch though. This isn't going to be able to move with the collision still on. At least the welded parts aren't. So what we're going to do is we're going to write a script to remove the collision on our door really quick. Local function, change collision. And so we'll say local value equals false. If state equals open, then state equals value equals true. So we keep the value at false if the state is open, we set the value to true. This is what we're going to set the parts can collide to. So let's loop through the door model. Say for index object in pairs doorway.door get children do. Let's check if object is a base part just to be double safe. If object is a base part, then continue. So if object is not a base part, then continue, skip it. Otherwise, object.canCollide equals value. So now we can just run right before we play the tween, change collision, and play our sound effect. So let's give this a try and see if it works. Okay, my C-frame calculation is off. Give me 1 second. Okay, I found the issue. It was this line here actually needs to go away. So we just create a new C-frame with move 2, and move 2 is the exact position that it needs to go in. So now if we test, now this is a little too fast for my sound effect, and it also needs a little bit of a delay. Okay, is this done? Perfect. Okay, it works. If that was hard to follow along, like I said, you can get the model for free. Description, website, download it, overlook the code yourself. I know there was a lot of issues there, especially with my math calculation, but now we've got a moving door, sound effects lined up. It's pretty cool. You can move these anywhere. We can also change the door size and it'll work. You can also try to interact with it as it's moving. Because of our state machine, it moves like it should and doesn't have any weird interruptions. So that's how to make a sliding door. If you guys have any other suggestions for stuff you'd personally like to see, different assets, different things, post it in the comments. If I like it, you'll see it on the next Feature Friday along with a shout out of your name and suggestion. Thank you guys for watching. Like and subscribe, do all that fancy stuff. I will add a plug because this video is sponsored. Drum roll, please. By me! I paid for this. If you guys want to support these videos, want to see more features, want to learn more things on Tutorial Tuesday and Feature Friday, check out my scripting course, The Basics of Roblox Luau. Teaches you everything you need to know from a complete beginner. The course takes you from start to finish, everything you need to know to make your first Roblox game. At the end of the course, we have this long module where it's a script along, where together we script a survival game, right? None of the basic tycoon simulator, no. Survival game. Hunger, thirst, inventory system, eating, food, everything you need to know to make a game like that. And we make it at the end. You get the place file. Hey, I mean, you could literally, like, buy the course, get the file, upload it yourself as your own game. I don't care. It's your file. The course isn't finished at the moment, so it's super discounted. As more videos release, which of course you get if you buy the course, you buy it now, you get all the modules that come out after, the price will go up. Pretty soon it's going to go up to $50 once a few more modules are added. So buy it now while you can. Thanks guys for watching. Like, subscribe.
Go watch another video. Love you.